divided by 101.96 times 3 divided by 2 times 44. 6.47. Grams carbon dioxide, because that was the only label that didn't cancel. So part A is telling us that we can use all 10 grams of aluminum oxide in order to make 6.47 grams of carbon dioxide. So we have to do part B now to figure out if we use all of our carbon, how much carbon dioxide can we make? Oh, I want red. So 2 grams of carbon. Grams of carbon goes on the bottom so we can cancel it. Moles of carbon goes on the top so that we're able to go to the other chemical. We want to get rid of it though, so moles of carbon goes on the bottom so that it cancels. And moles of the same product that we're trying to figure out, because that's going to tell us how much product we can make if we use all of the second reactant. So moles carbon dioxide goes on the top again. But we want to get rid of it because we're looking for grams of carbon dioxide. So this moles of carbon dioxide goes on the bottom so that it cancels. And I'm going to grams of carbon dioxide on the top. Go back, fill in our numbers. The misses again is in the middle because it has 2 different chemicals, both moles. Get the numbers from the coefficients. The coefficient in front of carbon dioxide is still 3. Coefficient in front of carbon is also 3. So those are going to even cancel out. Moles not in the misses are 1. Grams is off the periodic table. Grams of carbon is 12. Grams of carbon dioxide, again, carbon is 12, oxygen is 16, but there's 2 of them. You add that up, you get 44, which we also figured out here. So this problem says to take 2 divided by 12 times 3 divided by 3, but it's going to do the same thing, times 44, 7.3. So the one that can actually be made is the smaller one, because we would run out of this reactant. So the excessive reactant is the one that makes more. So to answer those 4 questions that I had written over here, how much product can be made is the smaller of the 2, so 6.47 grams of carbon dioxide. The limiting reactant is the one that had the smaller answer, so the limiting reactant is aluminum oxide. The excessive reactant is carbon. But now we have to do parts C and D to figure out how much excessive reactant we have used for part C. There's 6 out of the 9 parentheses that we have to do. Part C goes from the limiting reactant to the excessive reactant, and we figured out that the limiting reactant is aluminum oxide, the excessive reactant is the carbon. So part C, we're starting with the 10 grams of aluminum oxide again. We need that to cancel, so we're going to put it on the bottom of the parenthesis. And we need moles of aluminum oxide so that we can go to moles of the other chemical. Grams of aluminum oxide cancel with the grams of aluminum oxide here. I'm left with moles of aluminum oxide, but we need to get to carbon. So we need to put moles of aluminum oxide on the bottom so that it cancels. And moles of the carbon goes on top because we're trying to figure out how many grams of the carbon we actually used for our limiting reactant problem. We want to get rid of the moles of the carbon, so that has to go on the bottom so that it cancels. And we're trying to figure out the grams of carbon, so that's what can go on top. And that's the only label and chemical that don't cancel. So that's the label and chemical for our answer, which is what we were trying to figure out. Putting in our numbers, this is the misses because it's two different chemicals, both are moles. We use the coefficients for the numbers. Coefficient in front of carbon is 3. Coefficient in front of aluminum oxide is 2. Moles not in the misses, the number that goes there is 1. Grams is off the periodic table. Carbon is 12. And what was aluminum oxide? 101.96? Yes? You're really going to make me figure it out again?
I drifted.
Yep. Okay, if there's a number in the top, you multiply. If there's a number in the bottom, you divide. So you take 10 divided by 101.96 times 3 divided by 2 times 12. 1.77 grams of carbon actually used, which doesn't answer our question of how much of the excessive reactant is left over. And that's why we have to do a subtraction problem. So part D is the subtraction problem, where you take how much carbon you actually started with, which was the 2 grams from the problem. 2 grams of carbon from the cupboard. And we only used 1.77 grams of carbon. So you subtract those to figure out how much you actually have to put back in the cupboard. Okay, I'm done. For real, I'm done.
Done?
Done.
All right.